नमस्कार दोस्तों, myself Yogendra Prajapati, assistant professor from Ajay Kumar Garg Engineering College, Prajapati. Today I am going to teach minimization of the DFA. This is very important topic in respect of the GATE examination and with respect to the university examination and NEET examination also. Before going to teach the minimization of the DFA, first I explain what is the basic concept of the DFA and why it is required for the minimization. DFA stand for the deterministic. DFA stand for the deterministic finite automata. It means with the help of the single input, machine can move only one direction. Deterministic means the path of the machine are defined. These are the mathematical definition of the deterministic finite automata. In mathematical term, deterministic finite automata are classified into the 5 tuples: Q, sigma, delta, Q naught, and F, where capital Q is a set of state. It means in DFA how many states are consist. These type of the information we study in the section of the capital Q. Sigma is a alphabet, or sigma is also known as the input alphabet. It may be 0, 1, or it may be A and B. For the term of the computer, we take only the 2 inputs, that is 0, 1 or AB. But in the term of the machine, sigma may be more than 2 inputs, A, B, C, D, any kind of the input are accessed. Now, this is the function of the, this is the transition function of the DFA. Here we include Q naught 2 to power Q. It means Q0A, we find the state, that is the transition function of the DFA. Any state we give the input and machine move from the next state, that type of the information we study in the section of the transition function. Now, what is a Q naught? Q naught is the initial state of the machine, and it is also represented in Q, this one. For this diagram, Q naught are represent, or it is known as the initial state of the machine, and F is your final state. Final state when any kind of the problem are accept, or any kind of the problem are solved by the deterministic finite automata, then deterministic finite automata reached at the final state. And in the term of the DFA, this is the symbol of the final state. Okay. Now we move to the minimization of the DFA. First, I explain what is the required for the minimization of the DFA. In minimization of the DFA, minimum number of states are consist, and in original DFA, more than state are consist. Any problem, minimum DFA is unique, but any problem, DFA may more than one DFA are exist. So, minimum DFA is most important for implementing any kind of the problem. When we are going to minimize the any DFA, we follow the few steps. Now, this is the DFA. And in this DFA, if we explain the 5 tuple, then what is the capital Q? Capital Q is Q0, Q1, Q2, Q3 and Q4. This is your capital Q. Now, what is the Q naught? That is the Q1. This is the, this state is known as the capital Q naught. What is the final state for this problem? Q4 is your final state. Now, 3 tuple explain with the definition of the DFA in this problem. What is the next tuple? That is the sigma. What is the sigma? Set of input in this given problem. We have already explained that in the term of the computer, we take the only 2 inputs, 0, 1 or AB. So, similarly in this problem, we take only 2 input, that is known as the A and B. And what is the transition function of this problem? We simply explain this transition. Now, what is this transition? Q0, we take input A and move to state Q1. This is the transition function from this state to this state. Similarly, we can write any transition function from any state to another state. For example, if we write the transition function from Q1 to Q3, then what is the transition function? Q1 input is B, and what is the next state? That is the Q3. Another transition function for the Q1, that is Q1 A, and we find the same state, that is the Q1. With the help of this concept, we can write the all transition function for the deterministic finite automata. Now, this is the definition of the deterministic finite automata, and here I explain the 5 tuples. Now, we move to the another main important topic, that is the minimization of the DFA. When we are going to minimize any DFA, then we follow the few important concepts. What are these few important concepts? That deterministic finite automata, first we draw the transition table of the given problem. I have already explained by which method we write the transition function, and with the help of transition function, we draw the transition table. Now, Q1 is your initial state. From Q1 A, we find the state Q1. From Q0 to B, we find the Q2. This is the method by which we find the transition table of the any given problem. When we are going to minimize the DFA, the first step, we draw the transition table, and transition table draw with the help of the transition function. What is the transition table for the Q1? Now, Q1 A, we find the again Q1, Q1 B, we find the state Q3. Similarly, we draw the transition table of the Q2. Now, Q2 A, that is the Q1, Q2 B, we move from the same equation, that is Q2. Similarly, we draw the transition table of the Q3 and Q4. That is the step 1. Now, in step 2, these transition table divided into the 2 sets. These transition table divided into the 2 sets. The set 1, set of all non-final state. So, in this transition table, set of all non-final state, that is known as Q0, Q1, Q2 and Q3. That is the set of all non-final state. And what is the another set? That is Q4, that is the set of final state. Okay. Now, this is the we rewrite this one again because we use the set of final state and set of non-final state. Like this, Q4 and Q0, Q1, Q2 and Q3. That is the set 1 and that is the set 2. What is the step 2? This is the in step 2 or step 3, these two set that is Q4 and Q0, Q1, Q2, Q3. These two sets again divided into the subset on the basis of the transition function. Which state have same transition function lie into the same set, and which state have a different transition function lie into the different set. Now, Q4 is a single state, then it is no divide further. Now, this is the known as the first iteration and this is known as the first Q pi 0 pi 1. Now, we check the transition function of the Q1. If it is similar to any state, then Q1 and another state are lie into the same set. If it is not similar, then it is lie into the different set. Now, what is the transition function of the Q1? Q1 A, that is again Q1, lie into the same set. Q1 B, that is Q3, lie into the same set. We check Q0 A, that is Q1 set 1 and Q0 B, that is Q2, that is again set 1. If this property consists any kind of this set, then these two sets lie into the same set. We check the transition function of the Q1. Now, Q1A and Q1B. Q1A, that is Q1 set number 1, that is set number 2 and that is set number 1. Q1B, that is Q3 again it is set number 1. It means Q0, Q1 lie into the same set. Again check another state, that is Q2A and Q2B. Q2A, that is Q1, that is set number 1 and Q2B, that is Q2, again set number 1. It means Q0, Q1 and Q2 lie into the same set. We check another function, that is Q3A, that is Q1, that is set 1 and Q3B, that is set number 2. It means Q3 have a different transition function. It means that cannot be lie into this set. It means that is Q0, Q1 and Q2 have a different transition function. So, it is lie into the same set. And Q3 have a different transition function. So, it is lie into the different set. Okay. This process is continue until these two iterations are not same. We erase it. This process is continue until these two last two iterations are not same. So, with the help of this concept, we minimize the finite automata. Here set 1, set 1, set 2 and set 3. This process we repeat. We check the transition function of the Q0, Q1 and Q2. Now Q0A and Q0B. We check the transition function of Q0. We check the transition function of Q1 and we check the transition function of the Q2. If these three states have same transition function, they lie into the same set, and Q3 are already minimized, that is single set, further not minimized. Now Q1A that is Q1 and Q1A that is Q1 and Q1 is lie into the same set. Q0, yes, Q0, Q1 and Q2, yes. Now Q0B that is Q2 and Q2 again in set 2. Now we check the Q1. What is the Q1? Q1 again it is a Q1, that is a Q1, it has been set to Q1B, Q3 and Q3 in that is set 3. It means Q1 have a different transition function and Q0 have a different transition function. Now we check the transition function of the Q2. Q2A that is Q1, it is set to Q2B that is Q2 and it means Q0, Q2 have a same transition function. So these two states lie into the same set. What is the next iteration? That is Q4, Q0, Q2, Q1 and Q3. Because Q1 have a different function, but Q0 and Q2 have a same transition, so it is lie into the same set. Now, how many set are derived? 1, 2, 3, 4. 4 sets are derived, and this process we repeat until last 2 iterations are not same. Again we check only this. Again we check only Q0 and Q3 because this one is a single state, further not minimization possible. This one is a single state Q1, further it is not minimization is possible. And Q3 again also a single set, so further it is not minimization is possible. So we check only the transition function of the Q0 and Q2, Q0A and Q0B and Q2A and Q2B. We check the transition function of the Q0 and Q2. Q0A that is Q1, it is lie into the Q1 here, it means set 3. Q0B that is Q2 and Q2 lie into the set 2. That is the transition function of the Q0. And we check the transition function of the Q2. Q2A that is Q1 and Q1 that is set number 3. And Q2B, here is a Q2B that is Q2 and Q2 lie into the set number 2. It means the transition function of the Q0 and Q2 are same. It means these two states are minimized into the single state, that is pi 3, Q4, Q0, Q2, Q1 and Q3. If these two iterations are same, then stop the minimization, and this is your final solution. In without minimization, how many number of state are exist in this given problem? 1 2 3 4 5. And after minimization, 1 2 3 4 4 state are minimized. It means q0 and q2 are minimized into the single state. q4 not minimization, q1 again not minimized, and q3 again it is not minimized. Now this is your answer. This is your original DFA, and this is your minimal DFA. Or minimal DFA is always unique. Q0 and Q2 are minimized. Q1 is not minimized. Q4 is not minimized, and Q3 are not minimized. Given this example, we draw the minimal DFA like this. In minimal DFA, only 4 states are consist. 1 2 3 4. These two are same DFA, but here we take the transition state, that is A, B, C, D, and here is a Q0, Q1, Q2, and Q3. So this is the final answer for minimization of the DFA. For more understanding, we take another example to minimize the DFA. Steps are very clear. The first step, we draw the transition table of the given DFA. Draw the transition table of the given DFA. Second step, these states are divided into the two sets. These states are divided into the two sets, set of final state and set of all non-final state. And we check the transition function of the state. If these two states have same transition function, then lie into the same set. If two states have different transition function, then it is lie into the different set. So this is the overall views how to minimize any kind of the DFA. So we move another problem. Now in this problem, how many number of states are consist? 1 2 3 4. And how many number of final state and how many number of the non-final state in this problem? Then here is a 2 final state and 2 non-final state. So what is the first step? We draw the transition table. Q0 draw the transition table of this given problem. We draw the transition table of the given DFA. Here is a Q1 and Q2 and Q3. So these two states are the final state and these one state are the non-final state. Then what is the next step? We set of final state, that is this one, set of non-final state, and that is known as the Q1 and Q2. That is set of all. That is the final state. That is the non-final state. This is the single state. Further, no minimization is possible. This is the double two state. We check whether these two states have same transition function, then lie into the same set. Whether these two states have a different transition function, then it is lie into the different transition function. Now that is pi 0, and what is the pi 1? Pi 1, check the transition function of the Q1 A, Q1 B, Q2A, Q2B. If these two transition functions have same, then lie into the same set. And if these two transition functions are different, then lie into the different set. What is Q1A? Q1A, that is Q2, lie into the set 2. Q1B, Q1B, that is Q1, again it is set number 2. We check the transition function of the Q2. Q2A, that is Q1, and Q1 lie into this set number 2. And Q2B, that is Q2, and Q2 again lie into the same set. It means Q1 and Q2 have the same transition function. It means these two states are minimized into the single state. Now, what is the next expression? That is Q0, Q1 and Q2. If these two states are same, then further no minimization are possible. So this is your final answer. Now this is your final answer. 3 states are minimized into the 2 states. Now this is the these 2 states we consider as a state. Q0 consider as a state A. Q1, Q2 are minimized into the single state, that is known as the state B. I think concepts are clear, but for the better understanding, we consider another example, or this example asked in the GATE examination and AKG examination also. Now process is same. What is the first step? Draw the transition table. What is the second state? These states are divided into 2 parts: set of final state, set of all non-final state. And what is the step of number 3? These 2 sets check the transition function of the all state. If 2 states have a same transition function, then lie into the same set. If any state have a different transition function, then it is lie into the different set. Okay. Now the first step is over here. How many number of steps? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and draw the transition table. Here Q4 is your final state. And what is the next state? Set of final state. Now that is Q4. And what is the non-final state? Q0, Q1, Q2, set 1 and set 2. Now, what is the next step? We check the transition function of these states. If these states have the same transition function, then lie into the same set. If these states have a different transition function, then lie to the different set. Okay, now we check the transition function of the Q0, 0 and Q0, 1, Q1, 0, Q1, 1, Q2, 0, Q2, 1, and Q3, 0 and Q3, 1. Find the Q0, 0, that is Q1, and Q1 is line to the same, that is Q2 state, set number 2 state. Q01, Q3, now it is set number again 2. Now we check the transition function similarly on Q1. Q1, 0, that is Q2, and Q2 lie into the same set, that is Q2. Q1, 1, that is Q4, and Q4 lie into the same, into the different set. It means these transition function, the transition function of this state and the transition function this state are different. It means Q0 and Q1 are going into the different set. Okay, now we check further. We check the transition function of the Q2. Q2, 0, Q1, again set 2. Q2 1, that is Q4, it means it is 1. But Q0 and Q1 and Q2 have the same transition function. 2 1 and 2 1. It means these two sets lie into the same set. This Q naught have a different transition function. We check the transition function of the Q3. Q3, Q0 for Q2. Q2 it means set number 2. And Q3 1, that is 1. It means 2 1. It means what is the first iteration? Q4, Q0 have a different transition function, and Q1, Q2 and Q3. Q1, Q2 and Q3 have a same transition function, 2 1, 2 1 and 2 1. So it is lie into the same set, and Q0 have a different transition function, so it is lie into the different set. This process is continue. How many sets are exist? 1, 2, 3. We check the same process. We check the transition function of the Q1, Q2 and Q3, because Q naught is a single state, further it is not minimized. Now we check the transition function of the Q1, Q1 0 and Q1 1, Q2 0 and Q2 1, Q3 0 and Q3 1. Check the transition function of these three states. If any state have a similar transition function, then lie into the different set. If any state have a different, then it is derive another set. Now Q0 0, Q0 0, this is Q1, again lie into the Q1, and Q1 lie into the set number 3. Sorry, Q1, Q1 0, Q2, Q1 1, Q4, it means Q4, it's 1, 3 1. Q2, Q1, it means 3 here. Q2, Q4, 1 here. Q3, Q2, it means 3, and Q3 1, Q4 1. It means these three states have same transition function, 3 1, 3 1, 3 1. It means these three states minimize into the single state, that is pi 2, that is Q4, Q0, Q1, Q2 and Q3. This is your, these two states are same. Now this is your final answer. Q naught and this one, and this is your. Now these three states Q1, Q2 are minimized into the single state. 3, 4, 5, 5 states are minimized into the 3 states. So that is the magic of the minimization of the DFA, and number of states are minimized into the a small n number of the state. So this is your final answer. I think it is better understanding. We meet in next lecture for the more important topic of the theory of computation. Thank you all.